Hello everyone. Hope everybody's doing okay. We're fine here. In the house, go out for a walk. Big adventure is either going to get the mail or bringing the garbage out, but it is what it is. Everybody will all be fine. So let's take another look at locus. All right, you got to remember there are 5 different types of locus. The first one, when you're given a single point, your response to that is a circle. The next one, you're given 2 parallel lines. Points equidistant from those 2 parallel lines is one line between them parallel halfway. If you're given a single line, all the points equidistant to that one given line is 2 lines, one on either side, however the distance away you were given. All right. When you're given 2 fixed points, your response to that is the perpendicular bisector of the line that joins those points. Now, in some of the problems, 2 fixed points could be 2 houses, could be 2 trees, could be 2 rocks. So you got to use a little bit of imagination on that. But those really are the same 2 fixed points. And the last one, when you have 2 lines that intersect, or even a single angle, points equidistant from the sides of the angle is the angle bisector. Okay, so those are the 5. You're given one of 5 circumstances, and for each one of those 5 that we just talked about, you have a single response. Okay, so compound locus is 2 locus, 2 loci drawn on the same diagram. Okay, so let's see how this works. The difference between points P and Q is 8 units. How many points are equidistant from P and Q? Okay, so that's the first locus. So we're going to draw the perpendicular bisector of PQ. So we're going to draw that in. I'm going to do that in green. So this is the perpendicular bisector of PQ. All right. Oh, come on. It's not going. All right. I think I got it. Perpendicular. And they're congruent. So now let's think about this. P and Q are 8 units apart. The distance here is 4. And the distance here is 4. Okay. Now the second criteria we have is 5 units from point Q. Well, I have a given fixed point now. So 5 units from that is a circle with radius 5. Well, I know my distance to the green line is 4, so I have to go a little past the green line. So that's how we're going to draw 2 loci on the same problem. And what you wind up with, let me get my little stylus here. You have 2 points of intersection. I don't want to do that. One here and one here. So the answer to the question is there are 2 points that satisfy both criteria. Okay? Let's take a look at number 2. Number 2, you have lines L and M, which I drew out already, so you should draw them on yours. So pause the video if you need to do that. Point A is on line L, just anywhere on line L, it doesn't matter. I put it there randomly. So we need to be equidistant between L and M. Well, that would be a line halfway between them. I'll do that one in green. So that's halfway between. Now, if L and M are 12 units apart, the distance here is going to be 6. And the distance here will be 6. And it's important to have that frame of reference, because now when we look at the next criteria, 8 units from point A. Well, point A is a given single fixed point, so your response to that locus problem is a circle with radius 8. So now, when we look at that, I know if I draw it to the green line, my radius is only 6. So I've got to go a little past it to have a radius of 8. So again, how many times do the two different locus intersect each other? They'll intersect 2 times. One here and one there. Okay? So it's important you handle one like we did with the green line. Give yourself some points of reference. Then you address the second requirement, 8 units from point A. Now let's take a look at what one looks like on the coordinate plane. The number of units, 5 units from the origin. Well, the origin is a fixed point. So we're going to respond to that with a circle with radius of 5. So there's the first locus. Now, we want to be 7 units from the y-axis. Well, the y-axis is up and down, and we want to be 7 units away. So that's a line on either side of the y-axis, 7 units. So let's see what that one looks like. So we have a line here, and we have a line here. And so now when we look at our diagram, does the circle and those 2 lines intersect at all? No, they don't. So the answer is there are 0 points in the plane that satisfy this requirement. Okay? So as you read through these problems, remember you have 5 different types of locus, and each one has a unique response. Okay? So if you look at the classwork, you've got boulders that are 12 feet apart. He wants to plant trees that are 12 feet from each boulder. How many spots could he plant the trees? Well, this is a little deceiving because you have the 2 boulders and you have to draw a circle of 12 radius around each one. So they will pass the midline between the line that joins them, right? Because they're 20 feet apart, halfway is 10. So you need to draw a circle of 12 around each boulder and find out how many times the 2 circles intersect each other. Okay? So read through the rest of the classwork. And again, you have to look at it through the point of view of you've got 5 different types of locus. Each one has a different response. So I will see everybody in class, hopefully soon, before too long. I don't know. Nobody knows. Whatever. And as always, this lesson was brought directly to you from my dining room table.